Exercise number 4. The atoms that compose your body are mostly empty space, and structures such as the chair you're sitting on are composed of atoms that are also mostly empty space. So why don't you fall through a chair? When we look at the structure of an atom, this is the image that we see. We have a positive nucleus, and then we have these energy levels, and these energy levels have electrons in these shells here. Now, if I compare this to another atom that are sort of like composed of the chair, each of these atoms in a chair then have little tiny atoms like this. So that means when I look at each of these atoms, you have this little structure here where all the electrons live. So you could imagine that this thing here is the actual chair. So when you sit in the chair, your body is also made up of atoms. So then what I'm saying here, so these I'm going to say are the chair atoms. On the other hand, if you're talking about your bottom atoms, then you have atoms that also look like this here, where they also have these, shells as well. So remember, once again, these is where the electrons live. So if you go in and you sit in the chair, what you're going to see here is that your body is going to look something like this. And what you're going to find here is that the electrons, when I compare the electrons here from your bottom versus the electrons there, what you're seeing here is that I have a series of negative electrons that are coming in close contact, and as a consequence, you get this electrical repulsion. So that means here that there is electrical repulsion between the chair atoms versus the bottom atoms. And so as a consequence here, you don't fall through the chair. Exercise 5. Explain why the Rutherford model of the atom is not a good model. The Rutherford model is a planetary model. And that means here is that we treat the nucleus sort of like the sun and the electron as a little planet that goes around the nucleus. As it does that, we have an accelerating electric charge. So this electron is accelerating. And this electron accelerating implies it radiates light waves. And as it radiates light waves, it loses energy. And as it loses energy, this implies here is that the orbit of the electron will decrease and crash into the nucleus. So this implies here from the Rutherford model that the atom is unstable and dies off in 10 to the negative 8 seconds. So what is a good model of the atom? The quantum mechanical model. The quantum atom has electrons that live in energy levels. Okay, so these guys are energy levels. Electrons, once they're in an energy level, are stable. Electrons in energy levels do not radiate radiation. And because they do not radiate radiation, this tells us here that they're stable once they are at some energy level. However, electrons can jump from one energy level to the next. So if I have an electron here and it falls down to here, it will emit light. But it only emits light when it jumps energy levels. And therefore, this is our best model of the atom. Atoms can emit photons or light or absorb them. Explain how this happens. If I have an electron in an excited energy level, so let's say 1, 2, 3, 4, an electron can generate light as it falls from a higher energy level to a lower energy level. So this would then be a light wave that we see. So jumping electrons from higher to lower energy levels emit light, which sometimes we call photons. So that's how we actually see like green light. So if you talk about green grass, that means here that the electrons in the grass atoms are falling from a higher energy level to a lower energy level, and they are emitting green light. On the other hand, we can start with a lower energy electron. So in this case here, we see here that I have energy levels that may look something like this here. So if I have an electron right here, light, I could have light interacting with some atom. And what happens here is that when the atom absorbs light, the electron gets excited. So then what happens here is the electron then jumps up to a higher energy level to this state right here. So this means the atom absorbs light. The way red, blue, and green are created here, it depends on the size of the jump that the electron is making. So blue light has higher energy than green and red. So if I have an atom that looks like this, the electron that has the biggest jump or fall is going to emit blue light because it has more energy. On the other hand, an electron that has a smaller jump can emit green light. And since red has the smallest energy of all, when it falls, it will emit red light. Now, an atom is unique. With its number of protons, electrons, and shell number. This structure of the atom has unique energy levels. And because it has unique energy levels, its atomic spectra lines will also be unique. In other words, they're the fingerprints of atoms.